Hello, everyone. Today, we're going to investigate a very interesting question about acids and bases. You see, we know they are different, but what if I told you they have something very important in common? Let's find out together.
So let's start by thinking about this. In our science labs, we see so many different acids: hydrochloric acid, sulfuric acid, even the acetic acid that you find in vinegar. Now, these are all different chemical compounds, but they all share some common properties, don't they? They all behave like acids. So why is that? What is the one thing that is common to all of them? To solve this mystery, we need our first clue. And we're going to find it by looking at a very simple experiment. All right, have a look at this setup. It's a simple circuit. We have a beaker, a small bulb, and a battery. We're going to put different liquids into the beaker and see what happens. Will the liquid allow electricity to pass through and light up the bulb? Let's see. Okay, here are our results. When we use an acid solution, like dilute hydrochloric acid, look, the bulb glows. But when we use a glucose solution, the bulb does not glow. This is very interesting because both solutions have hydrogen. So what is making the acid solution so special? This is a very important clue for us.
So let's think about it. The bulb glowing means that an electric current is flowing through the acid. But how can current flow through a liquid? There must be something inside the solution that is carrying the electric charge.
And that something is what we call ions. Ions are tiny, charged particles, and because they have a charge, they can move through the solution and carry the electric current. So this experiment tells us that the acid solution must have ions. The glucose solution, on the other hand, does not. This is the key to our mystery. And this brings us to our first major discovery. All acids produce ions when they are in a solution, and more importantly, they all produce one particular type of positive ion, and that is the hydrogen ion, or H+. This is the one thing that is common to all acids, and it is this H+ ion that gives acids all their properties.
So we now know that acids produce these H+ ions. But are these ions always there? Or is something else needed to help the acid produce them?
To answer this, let's look at another simple experiment. This time, we will take some dry hydrochloric acid, which is a gas. We will test it with a dry piece of blue litmus paper and then with a wet piece of blue litmus paper. Let's see what happens. Now observe carefully. When we bring the dry HCl gas near the dry litmus paper, there is no change in color. Nothing happens. But the moment we use a wet blue litmus paper, it immediately turns red. This shows it's an acid. So what made the difference? What was the secret ingredient? And the answer is water. This is a very important point. Acids can only show their acidic properties when water is present. It is the water that allows the acid to break apart or dissociate and release its hydrogen ions. Without water, the H+ ions cannot form, and the substance does not behave like an acid.
So let's be very clear. The hydrogen ion, H+, is the particle that is produced by acids in water. And this H+ ion is what is responsible for all the acidic properties we know.
Now, just one more small detail here. These hydrogen ions, the H+ ions, they cannot exist all by themselves. They are very unstable. So as soon as they are formed in water, they immediately combine with a water molecule, H2O. This combination forms a new ion called the hydronium ion, or H3O+. So whenever we talk about H+ ions in water, we are actually talking about hydronium ions. All right, we have understood the secret of acids. Now, what about bases? Does the same logic apply to them? Well, the answer is yes, it does. You see, just like acids produce hydrogen ions in water, bases produce a different ion. They produce the hydroxide ion, which we write as OH-, and it is this hydroxide ion that is responsible for all the common properties of bases, like their soapy feel. Now, here is a special term you should know. Some bases can dissolve in water, but some cannot. The bases that are soluble in water are given a special name. They are called alkalis. So it's important to remember, all alkalis are bases, but not all bases are alkalis. Now that we know how important water is for acids and bases, we must talk about safety. Specifically, what is the safe way to mix a concentrated acid with water? This is a very important safety rule. I am sure you have all seen this warning sign on bottles in the chemistry lab. It shows that the chemical inside is corrosive, meaning it can cause damage. This sign is there for a very, very important reason. And that reason is this.
The process of dissolving a concentrated acid or a base in water releases a very large amount of heat. We call this an exothermic process. And because so much heat is released, it can be very dangerous if we are not careful. So, what is the correct way? The safe way is to first take the water in a beaker. Then, you must add the acid to the water, very slowly, bit by bit, while stirring the solution all the time. A simple rule to remember this is always add acid to water. A to W.
And what happens if you do it the wrong way? If you add water to the concentrated acid, a huge amount of heat is generated all at once. This can cause the water to boil and splash the acid out of the beaker. This is extremely dangerous and can cause severe burns, so please always remember the correct way.
Okay, so let's quickly summarize what we have learned today. First, acids produce hydrogen ions, H+, in water. Second, bases produce hydroxide ions, OH- in water. Third, and very important, water is absolutely essential for a substance to show its acidic or basic properties. And finally, for safety, always add acid to water slowly and with stirring.
So we have solved the mystery of what acids and bases have in common. But this leads us to a new question. We know some acids, like vinegar, are weak, and some, like battery acid, are very strong. So, how can we measure this strength? That is the question we will explore in our next session.